confidence intervals. So you need to also be ready with your statistical tables. We're going to introduce a new table today, but the other table, you have been using it. We have been using it with normal distribution and with sampling distribution. So by the end of the session today, we are going to cover the basic concepts of confidence intervals. You need to learn how to construct a confidence interval. And we're only going today to focus on the confidence interval for the mean. So we're going to look for when the population standard deviation is known, meaning it is given, and when the population standard deviation is unknown or it is not given. And if it is unknown, therefore it means they would have given you a sample standard deviation. And we're going to practice on this because the same concepts that we're going to learn today, when we do hypothesis testing, you need to always also remember them. And on Saturday, we're going to introduce the confidence interval for the population proportion and do more exercises, because then we will have a smaller session where we introduce this one concept. And then we can look at different questions relating to confidence intervals. Okay, so when we talk about confidence interval, it means we want to find a value that is not exact, but the value that falls within two values, right? It falls between two values, so that we are able to use that to estimate the point or the population parameter with that. So when we deal with confidence interval, we also going to introduce concepts like point estimate, which is just your sample statistic, which is just a single value or a single number that we're going to be using. We're going to use that sample statistic as our point estimate to estimate what the population parameters would have looked like. And that is the nutshell in terms of your confidence interval. It provides you with information about where your variable is located within that, the variability of that variable. So we are going to have to calculate those boundaries or those limits that we're talking about, the between the upper and the lower. So we're going to use a point estimate and estimate what the upper and the lower estimate or interval would be. And that is what confidence interval is all about. So think about it. When you do your calculations for confidence interval, always remember that you will have a lower limit and an upper limit where your point estimate can be located within that limit. So what do we mean by point estimate? Remember the difference between a parameter and a statistics. Parameters are measures that comes from a population, and they use the Greek letters. Like the population mean will use mu, proportion will use pi. Statistic are those measures that comes from a sample. And those are the ones we call point estimates. They estimate the value of your parameter. And those measures, we always use the normal letters of alphabet for them. So it's always simple and easy. Like X bar, the proportion will be P for a sample proportion. So you always need to remember that. So with confidence interval, we actually want to know how much uncertainty is associated with that point estimate of a population parameter. And an interval estimate provides information about the population characteristics than a point estimate. And I explained all these things in the beginning. And when we do all this, finding those interval estimate, we are doing what we call confidence intervals. So with confidence interval, because it gives you a range of values It takes into consideration the variation in the sample statistics from a sample to sample, because then you're going to pull from each sample, there might be different point estimates. It is based on only one sample, so it means you need to calculate your confidence interval based on that one sample that you have drawn. It gives information about closeness to an unknown population parameter, and you always state it in this format. So it is always stated in terms of the level of confidence. How confident are you? So we will never ever be 100% confident, but we will say it is 99% confident, or we say we are 95% confident, or we say we are 90% confidence, 98% confidence, and so on and so forth. Never 100% confident. So with an estimation process, remember, you get your population, you pull your sample, we take the point estimate from the sample, which is the mean, and then we do some calculations to find where the limits fall, and then we can say, if we have used a level of confidence of 95 or 95%, we can then say, I am 95% confident that the population parameter mean is between the value of 40 and 60. And that's how you can interpret your confidence intervals. And we're going to be able to calculate what the 40 is and what the 60 is using that 95% confidence level. So in a nutshell, the formula that we're going to use to calculate the confidence interval is as follows: is your point estimate plus or minus your critical value times the standard error. Now, there are certain things that we already discussed, and you should be able to understand what those are. For example, we speak about standard error. Remember, when we were talking about the sampling distribution, we spoke a lot about the standard error, which is the standard deviation of a sampling distribution, right? So when we calculate the standard error for the mean, we're also going to be using the same formula that we used in the sampling distribution, which is your population standard deviation divided by the square root of n. The point estimate, we already spoke about it. We always use the statistic point estimate, which means it's going to be X bar for the mean. So today we're only going to talk about the X bar. Saturday, we're going to introduce the P. So we're going to be using our point estimate as the X bar, which is the sample mean. Now, there are two things on this formula that I didn't talk to you about. Now I'm going to introduce them, which is the plus or minus. This plus or minus, the minus is always your lower boundary. Your plus is your upper boundary. So it means from this equation, you're going to say your point estimate minus the critical value times the standard error to find the value of your lower boundary. Always find your lower boundary first. Then you go and say point estimate plus the critical value times the standard error will give you the upper boundaries. So how we write the same formula, we can write it in this manner. The side will have the minus and this side will have the plus. And that tells you the boundaries. Otherwise, you can write it in this manner. This side will be the minus and this side will be the plus. Those are your boundaries. How we can write the answer. So we will write the answer in either one of the three formats when we calculate the point estimate. Now, the last component of this formula that I didn't touch, the critical value. You might think that critical value is something out there in the world in some way that you don't even know what that is. We have been working with critical value since we started with normal distribution. In this instance, where we find the confidence intervals for the mean, your critical value is the Z value. Previously, you would have calculated the Z value because they would have given you the values that you will use to calculate the Z value, and then use the Z value to go and find the probability on the table. Now we do the reverse of that. The critical value is your Z value. And how we find this Z value, we find it by using the probability value, which you're gonna learn just now, that the probability value, because we use the probability value. So previously you would calculate the Z, find the probability value. Now we move from the probability value to finding the Z value. So it means we go inside the table and go outside the table to go find the Z value. That's what we're going to be doing. So where do I get this probability value? Your probability value is your confidence level value. We're going to find it by using the confidence level, and from the confidence level, we're going to take out or find the level of significance, which is our probability, which is our alpha value. And you might think that, yo, this woman is confusing me. I'm trying to simplify it even further. So what did I say? Critical value is your probability value. And where do we find that probability value? From the confidence level. From this confidence level, we're going to find the probability value, which is our alpha value, which is called also our level of significance. Now, how do we find those things? Let's talk about that confidence interval or confidence level. That will give us this probability value that we are looking for. So a confidence interval will contain the unknown population parameter. We know that we have talked about it from the definition of confidence interval. When we find those confidence interval, it always relies or it's based on a confidence level. And a confidence level is always represented in a percentage form. Like 95%, 98%, 90%, 99%. Those are your confidence level. And also we can write this confidence level as 1 minus alpha. So this 1 minus alpha is our confidence level. Since we know that a 95% is made up of 1 minus alpha, then we can go and find the value of alpha, which is then our level of significance. So this alpha value is what we call the level of significance. Now, sometimes they will give you the confidence level, sometimes they will give you the level of significance. You need to make sure that you understand what is it that they have given you. I know that I'm introducing new concepts and new terms, but try to get it to understand the things that I'm explaining to you and how to differentiate the two. So, how do we find the level of significance? We're going to equate 1 minus alpha to 0.95 and then say, if we take alpha to the other side, it becomes positive, and we take 0.95 to the other side, it becomes positive, negative. So it will be 1 minus 0.95, which gives us 0.05. And that is our level of significance, and that is our probability value. Now, it does not end there. What I haven't said is, I only told you that we're going to use the probability value to go find the critical value. What I haven't said to you is, because the confidence interval has two sides, before we can go and find the Z value, we need to divide this probability value into two, so that then we have the lower boundary and the upper boundary level of significance value. So it means in order for us to go and find the critical value, we are going to take this alpha of 0.05 and divide it by 2, and then use that value of dividing that by 2, use that value to go find the probability on the table, and then use that probability on the table to go find our Z value. On the left, I'll find the first 2 digits, one before comma and one after comma, and at the top, I'll find the last digit. Okay, how do we do that? Do I want to go there right now? No, we'll get there just now. So with confidence interval, we're going to be looking at 2 areas: confidence interval for the mean and confidence interval for the proportion. So for the population mean, we also need to ask ourselves 2 questions. One, did they give us the population mean? If the answer to that question is yes, then you're going to use the Z table. If the answer to that question is no, then you're going to use a T table. And if the answer to that question is no, then it means, did they give you a sample standard deviation? Hence, we're going to go into the T table. So those are the things that you're going to ask yourself. So when you're looking at confidence interval, you're going to ask yourself actually 3 questions or 2 questions, let's say. Did they give me the mean? Then I'm doing the confidence interval for the population mean. Did they give me proportions, percentages? Then I will do for the population proportion. When I'm doing for the mean, am I given the population standard deviation? If not, then I know which one I'm gonna do. Did they give me the population standard deviation? If the answer is no, and they have given you the sample standard deviation, then you're going to use the T table. And that is what we're going to be doing today. We're going to only look at the population mean when the population standard deviation is known and when it is unknown. Let's first start with when it is known. When they have given us the population standard deviation, then the following assumptions also needs to be true. The population standard deviation has to be given or has to be known. The population has to be normally distributed. And if the population is not normal, then your sample size needs to be bigger than N of 30. So you must use a larger sample. So the formula to use to calculate the confidence interval will be your point estimate. In this instance is the mean plus or minus your critical value. And because remember I said if your population standard deviation is given, then we're going to be using the Z score or the Z test. Then we're going to find our critical value by using Z of alpha divided by 2. And where do I find my alpha value? From the level of confidence, and from there you're going to divide it by 2 times the standard error. And because we're doing for the population mean, the standard error will be your population standard deviation divided by the square root of N, because here we are given the population standard deviation. Okay, now how do we find the critical value? This is where I was trying to explain. So if we need to consider that we're doing a 95% confidence interval, then in order for us to find our alpha value, we're going to equate 0.95 to 1 minus 0.95 will be equals to 1 minus alpha. And our alpha, if we move alpha to the other side, or probably we can write it like 0.95 is equals to 1 minus alpha. And if we move alpha across from the equal sign, it becomes positive. 1 minus, if we move 0.95 to the other side, it's positive, it becomes negative 0.95. And our alpha value will be equals to 0.05 because 1 minus 0.95 is 0.05. Okay, and that is our alpha value. But we need to go and find the critical value because we know that we're doing a two-tail confidence interval. So we need to divide this alpha. So we're going to divide the alpha by 2. And when you divide 0.05 by 2, you're going to get the answer of 0.025. And therefore, you're going to have two sides on the lower boundary or lower limit and the upper limit. We are not done. We have this value. That value is what we call the probability value. It's the same thing as our alpha value. It's also, but because we're taking the alpha value and dividing it by 2, we're creating another value. So it means we're splitting alpha by 2, and that is our probability that we're going to be using. Remember also, alpha is also your p-value. It's also your probability value. And later on, don't get confused when we start introducing words like p-value. They mean the same thing, probability value. It's going to be shortened later on to and call it a p-value. It's the same. It's the probability value. Now, how do we then find the critical value? And we said the critical value is our Z value if we are looking at the Z table. So let's go there. So we need to find inside the table the probability. Remember, this is a Z table, right? It's our cumulative standardized normal distribution table, which we call the Z table that we use in normal distribution, in sampling distribution. Now we're using it in confidence interval. We used to calculate the Z value and then come to here and take the Z value and find the probability inside the table. My pen is stuck and my screen is stuck. Apologies. Are you able to still hear me? Or am I gone?
Yes, we can hear you.
And what are you seeing right now?
Teams.
I'm not sharing anything. Are you not seeing anything?
Correct. We can just see Teams.
My screen was frozen. Okay, I'm going to assume that you are not seeing anything. And now you see the presentation, right?
Correct.
I can see it.
Okay, cool. All right, so how do we then find the Z value? So like I said, previously, it's back. Previously, we would calculate the Z value and use the Z value to come and find the probability. Now we need to come inside the table and find a value of 0.0250 inside the table. So let's go find that value. 0.0, 0.0000002, 0.025. And there is the value that we are looking for. And once we have that value, which is our alpha divided by 2 value. So since we have this value, 0.250, from there, we're going to go out with that value and find the first Z value, which is minus 1.9. And then we're going to go up and find the last digit. So it means our critical value, we're going to ignore this minus for now. We're not going to worry about the negative. We're going to say our critical value is 1.96. So since our critical value is 1.96, we can then put the plus or the minus because it is part of that confidence interval. So When we put it on the lower boundary, it will have the minus 1,96. When we put it on the upper boundary, it will be positive 1,96. And that's how you will find the critical value. Now, let's play around before going to do some exercise. Oh, come on. I cannot even clear the ink. Let's see if I can clear it from here. Okay, great. So let's say, let's find a 90. Oh, come on. Let's find. Now I cannot write the. Okay. I broke my PowerPoint. I was going to say, let's find this cut and reshare again. Maybe it will come back. Let's go find, instead of 95, let's go find a 98% confidence interval. So if they have given us a 98 confidence, so we can say it is 0,98 is equals to 1 minus alpha. And that will be, we bring alpha to this side, and this will be 1 minus 0,98, which is equals to 0,02. In order for us to find the critical value, we're going to have to divide our alpha by 2. So we're going to say 0,02 divided by 2, which is 0,01. So our critical value will be 0,01. So it means we're going to go inside the table and look for 0,01. So let's go to the table. We're gonna go inside the table. So let's remove this in. Okay. We are looking for 0,01. Sometimes it's not that easy to find some of these values, so you will have to use some judgment. So inside here, we're looking for 0,01, 0,0878, 07, 04, 0102, 099. So it's somewhere between those two. This one already passed by at least 2. This one is less by 1. So I'm going to use this one. So instead of using that, because the difference between that and this is 2, this is 1. So I'm going to use the one that is lower. So this will be my 0,01 if I round it off. And I'm going to go out and say my critical value will be 2,3, and I'm going to go up and it will be 3. So my Z of 0,01 is 2 plus or minus 2,33, and so forth and so on. There is one exception to the rule. Let's say we want to do a 90%. So it will be 0,90 is equals to 1 minus alpha, and our alpha will be equals to 1 minus 0,90, which is equals to 0,10, and our Z of alpha divided by 2, which is the Z of 0,10 divided by 2, gives us Z of 0,05. Now, I need to go and find 0,05 from the table. And this is where the exception to the rule comes in. And you will always have to remember that. So come inside that, we're going to look for 0,05. 0,0 0,000010204. We're still gonna go 0,0 0.5, 0.6, 0.5, 0.5. I need to go 0 somewhere there. So if you look at this one, the difference here is addition of 5, and the difference here is addition of 5 to make it 0.05. So there is a 5 on both sides. And since it's 5 on both sides, then our critical value will be divided by both. So on this one, we're going to take our Z value of minus. Oh, we're not worried about the minus. We're going to take our Z value as 1.6. And when we go to the top, we're just going to use 4.5. Half of it. 4 plus 5 will give you 4.5. So that will be your critical value at 90% confidence interval. Now, you can learn how to find the confidence intervals, the critical values by using the formulas like this, or you can memorize this table. There are common confidence levels that are used in your module: 90, 95, and 99. Those are commonly used. Sometimes they do include 98, but 95 is the most one used, and 90. So if you're doing a confidence level of 90%, remember your confidence level will be 1 minus alpha, which is equals to 0.9. Your critical value, which is alpha divided by 2 after we have done all the calculation, will be 1.645. If you're doing a 95, it's 196. If you do it 99, it's 258. If you do it 98, it's 233. As you can see from the activity that we did, we found that one, and that one. You can do for 80, you will find 1.38. If you do for a 99.9, you will find 3.27, and so on and so forth. And these are your confidence levels, and they are corresponding critical values. Okay, so let's use this in an example. A sample of 11 circuits from a normal population has a mean resistance of 2.2. We know from the past testing that population standard deviation is 0.35. Determine a 95% confidence interval for the true mean resistance of this population. Now, what is it that they have given you? They have given you the mean. They have given you the sample, because they're telling you that a sample circuit from a large population has the mean. So this mean comes from this sample, right? It's not the population mean, it's the sample mean. So we have our N, we have our X bar, and we have our population standard deviation. So they are giving you, it is known. So it will be the population standard deviation. They have given you your 1 minus alpha of 0.95. I don't have to do the alpha divided by this and that. I already know most that. That alpha from this will be 0.05, right? And you need to know that you need to go and find alpha over 2, which is 0.05 divided by 2, which is 0.025. So you have your Z of 0.025, which is equals to 1.96. We already found that. It was the first activity that we did. If you don't believe me, there it is. If you don't believe that we did that, it was this graph that we did. We found at the 95% confidence, our alpha divided by 2 was 0.25. Our critical value was 1.96. Okay. So we have all that. So now let's go and find this confidence interval. We know all that. We substitute. Our mean is 2.20. Our critical value, we found it, it was 1,96. Our population standard deviation is 0,35. Divide by the square root of 11, because it's divided by the square root of n. And you can calculate the left or the right-hand side. And when we calculate this right-hand side, this whole formula, which I can just also introduce, we are calculating here what we call the margin of error. So the margin of error is your critical value times your standard error. Critical value times your standard error, it gives you the margin of error. My pen. Your critical value times the standard error gives you a margin of error. So our margin of error in this instance is 0,20868. That is what the margin of error is. In case they ask you to find the margin of error, that's the margin of error. So you calculate the margin of error and you find that it's 0,2068. Your point estimate plus or minus, because we're doing plus or minus, so we can calculate from this side. We do a, oh, sorry. This value, it was found by saying 2.20 minus 0.2068. And this side, it was 2.20 plus 0.2068. So that will give us that the mean lies between 1,9932 and 2,4068. I told you that I'm going to use them both interchangeably. So this is how we write the confidence interval in your module, but you can also still write them like this. But you will see that most of the time when you do activities and exercise, it's written in the bracket format. Okay, and that's how you do confidence interval. Now let's introduce confidence interval for when the population standard deviation is unknown. So when the population standard deviation is unknown, then the following assumptions needs to hold. Your population standard deviation obviously is unknown. Your population is normally distributed, and if it's not normally distributed, then the sample size needs to be larger. Then we're going to use the t distribution, and the formula will be, instead of using the z critical value, we're going to use the t critical value. Now, with the t critical value of alpha divided by 2, it also has what we call a degrees of freedom, and our degrees of freedom is n minus 1. So you'll have to have two values, your probability value and your degrees of freedom. We're going to get there times the standard error. So how do we find the critical value on the t table? Okay. How do we find this critical value? To find this critical value, I'm going to use, let me see which exercise here I'm using, a 95% confidence interval as well. 95% confidence interval. So therefore, it means our alpha here is 0,05. So in order for us to find the critical value, we are going to use that alpha of 0,05. We're going to have to find the n sample size. So let's look at our example. Let n is equals to 3. The degrees of freedom then will be your n minus 1. So it's 3 minus 1, which will be equals to 2. Your alpha, in this instance, we're using an alpha of 0,10. So it means we had a 90% confidence interval. And we divide that alpha by 2, we get the value of 0,05. So now we have our t of 0,05 and the degrees of freedom of 2. I don't want to use this table. I'm going to go to the actual table so that you can see, because we're introducing a new table. So we're going to move away from the Z value table. So now, so far, we've introduced 3 tables. We're going to introduce the 4th table. So you need to always remember those things. So you need now to use a critical value of T table. Like I said, every week we have a session, or every 2 weeks or 3 weeks we have a session. We're going to be introducing a new table. So today we're introducing a T table. Now, how do we read the T table? Ignore all this that says cumulative probabilities. We're not going to use them. We're not even going to look at them. We're not even going to even try to understand what they mean or anything like that. So we ignore those ones. We're only going to use the upper tail areas, values that are closer to the data table. We have the degrees of freedom. So therefore, it means our alpha divided by 2, which is our alpha values, are these values here. So remember, our alpha was 0,05. Our degrees of freedom was equals to 2. So we're going to go to the degrees of freedom of 2 and come here and look for 0,05 where they both meet. That is our critical value. Make the table bigger. Make the table bigger, 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 bigger. So our degrees of freedom of 2 and our alpha value of alpha divided by 2 value of 0,05 gives us the critical value of 2,92. Also remember, 2 sides, the negative side and the positive side of the critical values. Okay, so we're going to use the plus or minus. So there is also this side, which will have the minus 2,920. Okay, so let's look at an example. A random sample of n is equals to 25 has x of 50 and s of 8. And time is almost done. So we're not going to be able to do any activities today. Form a 95% confidence interval. So our degrees of freedom, it's n minus 1. So our n is 25. So it will be 25 minus 1, which is equals to 4. Our alpha, the 95% confidence interval. So therefore, our alpha will be 0,05. We divide 0,05, we get our T critical value will be found by using 0,025 and a degrees of freedom of 25. So let's go find that critical value on the table and not rely just on the answer that I have. So you go to the table, we look for, make it smaller again. We're going back to being small. We look for 24 and we go up. We look for, what are we looking for? 0,25. 0,025. So it's 24 and 0,025 where they both meet. That will be our critical value. So our critical value is 2,0639. 2,0639, and we substitute into the equation. Now, our population standard deviation is unknown because they didn't give us, but they gave us the sample statistic sample standard deviation. S is your sample standard deviation. Substitute our, there should be an X bar there. Our X bar is 50 plus or minus our critical value of 2,0639 times our sample standard deviation of 8 divided by the square root of 25. You calculate the margin of error. 50 minus the margin of error gives you 46,698. 50 plus your margin of error gives you 53.302. And that's how you will answer the question. I know that is too much for one day. Are there any questions, comments, anything? We're not going to do any activity because time's up.
Not from my side, Lizzie.
Okay. On that note, if there are no questions or no comments, then